So dear class 11 students, here we are starting new topic in probability, that is addition law of probability. Addition law of probability. This is most important in probability theory. Addition law is most important. The statement of the theorem is, if A, B are any two events associated to random experiment, P and B are any two events associated to a random experiment, then P of A union B is equal P of A plus P of B minus P of A intersection B. This is the statement of the theorem. Now we prove this using Venn diagrams. Sample space S is the event A, this is event B. Okay, so this is A intersection B complement, this is A intersection B. Are you following? This is A complement intersection B. Right? Now proof. See, A intersection B complement and B. Are you following? A intersection B complement and B are disjoint events, right? So as I said, A intersection B complement and B are disjoint events. So A intersection B complement B and B are disjoint events. And their union, if you take the union of these two events, A intersection B complement and B, it covers A union B. So if you apply probabilities on both sides, probability of A intersection B complement union B is equal to probability of A union B. So this is equal to, as they are disjoint events, now the union probability is equal to sum of the probabilities, is equal to P of A union B. So we got now P of A union B is equal P of A intersection B complement plus P of B. You got this. Say this is equation 1. Now you keep it aside, this equation. Now again, see A intersection B complement and A intersection B. You see in the diagram, I am doing this proof strictly basing on the diagram. A intersection B complement and A intersection B are disjoint events again. They are disjoint events. Their union You see their union, the union of these two events covers A. So if you apply probabilities, now this union becomes, because they are disjoint events, their union becomes, okay, sum of the probabilities. So P of A intersection B complement plus P of A intersection B equal to P of A. So by transposition, okay, P of A intersection B complement is equal P of A minus P of A intersection B. Now you have that equation 1. Therefore from equation 1, P of A union B is equal. Now here P of A intersection B complement is there, no? That has to be replaced with P of A minus P of A intersection B. And in the equation 1 we have, in the equation 1 if you check, P of A union B is equal P of A intersection B complement plus P of B is there, and P of A intersection B complement I have replaced with P of A minus P of A intersection B plus P of B. So P of A plus P of B minus P of A intersection B. Hence the addition law of probability is proved. Understood? Now dear student, you see addition law of probability extension for 3 events. We are extending for 3 events. If A, B, C or any 3 events associated to a random experiment, then P of A union B union C is equal P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. This is the extension law for addition probability. It is extended, law of addition probability is extended for 3 events. Understood? Dear students, now we are going to discuss a theorem. For any 2 events A and B, show that P of A intersection B is less than or equal to P of A is less than or equal to P of A union B is less than or equal to P of A plus P of B. Okay? See, so I am taking a Venn diagram just for sake of idea only. Okay? So now we are going to prove this. We know that A intersection B is a subset of A. So if you see the diagram, it will be very clear for you. A intersection B is this. This is A. So intersection B is clearly subset of A. Then obviously P of A intersection B is less than or equal to P of A. So this is one. And now A is subset of A union B. It is also okay, clearly observed from the diagram. So P of A is lesser than or equal to P of A union B because it is a subset. So this is 2. Next, from addition law of probability, P of A union B is equal P of A plus P of B minus P of A intersection B. So obviously P of A union B is less than P of A union B is less than or equal to P of A plus P of B. Obvious, because P of A union B is sum of these two subtracted from sum of these two, P of A intersection B is subtracted. So P of A union B is obviously less than or equal to, okay, P of A plus P of B. Did you understand? See, for example, 9 is equal, okay, 10 plus 15. So 10 plus 15 is 25. 25 minus 16. Suppose 9 is equal 10 plus 15 minus 16. 25 minus 16 is 9. So 9 is sum of these two minus 16. Then obviously this 9 would be, okay, lesser than 10 plus 15 only. So that's what I wrote here. Okay. So now this is 3. Now combining the facts in 1, 2 and 3, then what we'll have? Therefore P of A intersection B less than or equal to P of A is less than or equal to P of A union B less than or equal to P of A plus P of B. Hence the theorem is proved. Understood? Now dear students, we are going to solve some problems, interesting problems. Find the probability of getting an even number on the first die or a total of 8 in a single throw of 2 dice. So solution. So S is equal to, okay, 1, 1, 1, 2 like this. 2 dice are thrown, no? So up to 6, 6. So number of sample points 36. So now A is equal getting even number on the first die. Even number means 2, okay. Now this 2 should be on the first die and no matter what number appears on the second die. So 2, 1, okay, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Next even number 4. So 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Next even number 6. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So for getting an even number on the first die, so these are the favorable outcomes. So 6, 6, 12, 18. So n of A is equal to 18. Now what is B? The total must be 8. If you add the numbers on the two faces of the dice, you should get 8. Okay? So 2, 6, 6, 2. Okay? 3, 5, 5, 3. Right? 4, 4. So these are the favorable outcomes for B. The total must be 8. So if you add the numbers, it should be 8. So n of B is equal, how many are there? 1, 2, 3, 4, 5 are there. So n of B is 5. Now let us find out A intersection B. Common elements in A and B. So what are the elements you are seeing as common? You are seeing 2, 6, right? 2, 6 is there in A. Of course 6, 2 also common. Now 3, 5 is not there, 5, 3 is not there. again 4 4, you are seeing that. So these are the three elements which are in common for both the sets A and B, which is clearly not equal to empty set. Okay, so now required probability, this or that, A or B means A union B. I have given a table, no, on that day. So required probability is P of A union B to P of A plus P of B minus P of A intersection B. P of A is N of A by N of S. N of A, how much did we see? 18 by 36. P of B is N of B by N of S. N of B is 5 by 36 minus 3 by 36. Right? Now if you go for LCM, 36 is LCM. So 18 plus 5 minus 3. So 18 plus 5, 23. 23 minus 3, 20. 20 by 36. Are you following? 4 5s are 20, 4 9s are 36. So P of A union B is equal 5 by 9. This is the answer for this question. Understood? So dear students, this is another question. An integer is chosen at random from the numbers ranging from 1 to 50. What is the probability that the integer, okay, an integer is chosen, no, at random from numbers ranging 1 to 50. What is the probability that the chosen integer is a multiple of 2 or 3 or 10? So if you go for sample space, it is 1, 2, 3, so on up to 50. So N of S, I am doing solution now. So N of S is 50. Now A is a multiple of 2, say. So 2 to the 4, 2 3 is 6, 225 is 50. So N of A is 25. Now B is a multiple of 3. So B is a multiple of 3. So 3 1s are 3, 3 2s are 6, so on, 3 8s are 24. Okay, and so on. Okay, right? Are you following? 3 16s are 48. This is the last multiple of 3 below 50. 3 16s are 48. So N of B is 16. Now C is a multiple of 10. 10 1s are 10, 10 2s are 20, 10 3s are 30, 10 4s are 40, 10 5s are 50. Only few number of elements are there, so I have written in, okay, all elements I have written. So overall how many are there? 1 2 3 4 5. So N of C is equal 5. Now go for A intersection B. A multiple of 2 and as well a multiple of 3. A multiple of 2 and as well a multiple of 3. So it is a multiple of 2 as well 3. Okay. So you can take 6, right? And then, okay, 12. The multiple of 2 as well 3. 18, 24, 30, 36, 42, 48. So these are all the multiples of 2 and as well 3. It's nothing but a multiple of 6. Okay. So n of A intersection B is equal to 8. Right? Now B intersection C. B intersection C means it is a multiple of 3 and as well it is a multiple of 10. So it is nothing but a multiple of 30. So it is only one element is there. So n of B intersection C is equal to 1. Next, A intersection C. It's a multiple of 2 as well, it is a multiple of 10. So it is a multiple of 20. So you have 20, 40. So n of A intersection C equal to 2. Now n of A intersection B intersection C. Now we require this. For that you have to find out A intersection B intersection C. It is a multiple of 2 and 3 and 10. The multiple of all the three numbers 2 and 3 and 10. Okay. So what is such number exist which is a multiple of all the three numbers in this? Tell me. So an integer which is multiple of 2 and 3 and 10 you are seeing, okay, it is only 30. It is a multiple of 2, it is a multiple of 3, again it is a multiple of 10. So only one number you are seeing. So n of A intersection B intersection C is equal to 30. 1. If you go for number of elements in this set, it is 1. So you could find okay, n of A, n of B, n of C, all you could find. So now you have to go for the formula. Okay. So P of A union B union C is equal. I have given now that extension formula P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. So P of A is n of A by n of S. So n of A, how much did you get? 25, right? Right? N of A means multiples of 2. So 25 you got. So 25 by 50, this you got 16, 16 by 50. N of C, how much did you get? 5. So 5 by 50 minus 8 by 50 minus 1 by 50. Okay. Intersection C, how much did you get? 2. Okay. So 2 by 50. Are you following? Plus 1 by 50. Dear students, this problem went wrong. So I am doing the same problem once again, you can check it off. So dear students, that problem is an integer is chosen at random from 1 to 50. What is the probability that the integer chosen is a multiple of 2 or 3 or 10? So solution. We write the sample space, it is 1 to 50. So n of s is equal 50. A is multiple of 2. So 2, 4, okay, 6 and so on up to 50. So n of A is 25. B is a multiple of 3. So 3 1s are 3, 3 2s are 6, okay, 3 3s are 9, like this. So you go up to 48 because our last number is 50. Below 50, the 3 multiple is 48. Okay, so n of B is equal 16. C is a multiple of 10. So 10, 20, 30, 40, 50. So C is this set. So n of C is 5. Now go for A intersection B. Multiple of 2 and as well multiple of 3. So it is nothing but multiple of 6. So okay, so 6 1s are 6 2s are 6 3s are, like this. You have to go up to number which is 50 or less than 50. Okay, so it is 48. So n of A intersection B is 48. It is 6 to 48 means how many are there? 6 1s are, 6 2s are, 6 3s are, and so on. Okay, 6 8s are, right? So n of A intersection B is 8. Now B intersection C. So it is a multiple of 3 and as well it is a multiple of 10. It is a multiple of 3 and as well it is a multiple of 10. So it is nothing but it is a multiple of 30. So 30 is the only number you get which is both multiple of 3 and 10. Right? So n of B intersection C is 1. Now A intersection C is a multiple of 2 and 10. It is a multiple of 2 and it is a multiple of 10. So it is nothing but a multiple of 10 then. 10, 20, 30, right? 40, 50. Multiple of 2 and as well multiple of 10. 10, 20, 30, 40, 50. 1, 2, 3, 4, 5. So n of A intersection C is equal to 5. Next, A intersection B intersection C. So multiple of 2 and 3 and 10. Right? So multiple of 2 and 3 means multiple of 6. Right? So multiple of 2 and 3 and 10. So what is that? It is nothing but multiple of 30. So 30 only number you get. So n of A intersection B intersection C is equal to 1. Did you understand? Now P of A union B union C is equal, formula you know, P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. So, which is equal N of A is 25 by 50, 16 by 50, okay, and P of C means N of C by N of S, which is 5 by 50, minus A intersection B. How much did you get? N of A intersection B, it is 8. So 8 by 50. B intersection C is 1 by 50. A intersection C 5. So 5 by 50. N of A intersection B intersection C, how much did you get? 1. So it is 1 by 50. Now what will happen? This minus 1 by 50 plus 1 by 50 get cancelled, right? Then this is 50 if you take LCM, 25 plus 16 plus 5 minus 8 minus 5, right? Now this plus 5 minus 5 also get cancelled. So it is equal 25 plus 16 minus 8, 8 by 50. 25 plus 8, 33. 33 by 50 is the required probability.